Hello friends, as discussed in last session, Q is a data structure. Which category? Non-primitive linear data structure. So all of us are knowing about Q. You must be experience Q in various domains of your life, like for purchasing any movie ticket or going at some government office, or for consulting the doctor. There are various ample number of examples where Q is applicable. Just think, if you are going to visit some place, or you are going to purchase some movie ticket, and if we apply stack, what will happen? Recent most who will be inserted will get the ticket first. So just think, at what moment, in which situation, which data structure should be applied. So just think about printing. So at that time Q should be used or stack, but obvious Q, because first in first out manner is required. Then same way job scheduling in operating system. Then there are various applications like keyboard input stream, so that at that time Q is required. Same way there are number of applications like downloading, file buffering, then copy paste, all these areas where we can implement Q. So let's discuss some basic parameters and how it gets implemented in computer science. So Q, as you know, there are two ends in a queue always. One end for insertion and another one for deletion. So always from one, like consider one counter from where the queue is getting processed, like ticket window, we can assume that, and let's assume here there is a queue. Okay, so this here, this end we'll call it front end. Okay, so the frontmost one will be processed first, then another will be here in rear end. The elements will get inserted like this and so on. So this is rear end, right? So there are two ends. Now which end will be used for insertion? But obvious, this end will be used for insertion, and from this end the elements will get deleted, right? So now to implement this, how many pointers are required? In stack there is only one pointer, top, because there is single end in stack and last in first out. But here there are two different ends for insertion and deletion. So for insertion we'll use this rear end, and for deletion we'll use front end. So two pointers will be required. We'll call it F and R. F then for front and R for rear. So which pointer will be used for deletion? Pointer F. And which pointer will be used for insertion? Pointer R, right? So next, now how can we implement this? So suppose there are 4 elements in a queue. It is called number of memory cells, means maximum you can store 4 elements in this queue, right? So initially what will be the position of front and rear? Both will be pointing to null, means currently assume that F and R is equal to 0. Consider this as first, second, third and fourth. So left to right, the leftmost is the frontmost, right? Now right now Q is empty. So what is the position of F and R? We'll call it 0. Now when first time insertion happens, what will happen? R pointer. Which pointer will be used for insertion? R. So let's say we want to insert 10. So at which position 10 will be inserted? Frontmost position, that is leftmost. So here 10 is to be inserted. Which pointer is to be used? R. So we'll move this R pointer where it will be moved to 0 to 1. So here R, so R will become 1, and now at this position 10 will be inserted. Now consider this as an array Q. So index, so Q of 1 is this one, 2, 3, 4. Conventionally, like in algorithm, we'll start the index of array from 1. In programming generally we use it from 0. So anyways, here we'll consider it as 1. So Q of which position? Rth position, that is right now 1. So at Q of first position we'll insert the new value, suppose x. So Q of R equals to x. Here what is x? 10. So Q of 1 will be 10. Alright. Now it is first time insertion, so F is still 0. So just consider, when you are alone in any queue, who will be the front and who will be the last? You yourself. So when there is a single element in a queue, that same element is front as well as rear. So here the same position is there, 10 is there only in a queue. So 10 itself is a rear and itself is a front. So front will also become 1, right? So this is first time insertion. Now very simple. Let's insert 20. So again R will be moved to second position, R equals to R plus 1 all the time. So now R will be at R's position, that is Q of 2 will be X. So Q of 2 will be 20, right? Same way 30, 40. So after inserting 40, R will be 4, right? After that, if we try to insert 50, what will happen? We cannot accommodate that. So R has reached to nth position. N is total number of elements we can store in this queue, that is 4, it's given. So after 4 elements, we cannot insert the fifth one. So when R becomes n, means what is the condition? If R is greater than or equals to n. So after that, the queue will be overflow. So what is the condition for overflow? If R is greater than or equals to n, queue will be overflow. Same way, when the queue will be underflow? When all the elements are deleted, means front and rear are 0 at the previous position. So this is how we can implement insertion in queue. We'll see the algorithm in detail in next session.